Aluminum wiring presents unique challenges that require careful assessment and mitigation. Firstly, conduct a thorough inspection and repair. This involves inspecting all outlet boxes, switch boxes, and junction boxes for loose connections, burn wires, and damaged insulation. Always test connections with a voltage tester or continuity checker. Make necessary repairs and replace any damaged wires or components. It is essential to tighten all connections to the recommended torque specifications. Secondly, consider arc fault detection methods. While there are no commercially available arc fault receptacles specifically designed for aluminum wiring, you can explore arc fault circuit interrupter, or AFCI, breakers. Install AFCI breakers in the sub-panel to detect and trip the circuit if it detects an arc fault. Note that AFCIs may not be fully effective with aluminum wiring. You can also look into arc fault detection and disconnection, or AFD, devices. These devices are designed to monitor the circuit for arcs and trip it quickly in the event of a fault. AFDs are more sensitive than AFCIs and may be more suitable for aluminum wiring. Thirdly, wiring modifications might be necessary. If the customer is willing to invest in a more comprehensive solution, consider replacing the aluminum wiring with copper. This is the most effective way to eliminate the potential for overheating and arcing due to aluminum wiring. If replacing the wiring is not feasible, you can explore pigtail connections. Use copper pigtails to connect the aluminum wires to copper wires at junction boxes, switches, and outlets. This helps reduce the resistance at the connection point and minimizes the risk of overheating. When making connections, use wire nuts specifically designed for aluminum wiring and apply anti-oxidant paste to the connection before tightening. This helps prevent corrosion and maintains a good electrical connection. Fourthly, adhere to proper wiring practices. Ensure that all wiring follows the National Electrical Code, or NEC, and local regulations. Use the appropriate size conductors and wire types for the amperage and voltage of the circuit. Secure wires properly using straps, clamps, or conduit to prevent loose connections. Fifthly, establish monitoring and maintenance protocols. Implement a regular maintenance schedule to inspect the electrical system for any signs of problems, such as discoloration, overheating, or loose connection. It is crucial to inform the customer about the potential risks associated with aluminum wiring and provide them with instructions for reporting any issues promptly. Addressing these concerns proactively can significantly improve the safety and reliability of the electrical system. Understanding the specific challenges posed by aluminum wiring is vital for implementing effective solutions. Aluminum wiring was commonly installed in residential buildings between the mid-1960s and the mid-1970s due to the rising cost of copper. However, it has several properties that make it less desirable than copper for electrical wiring. These include higher electrical resistance, greater thermal expansion, and a tendency to corrode where in contact with certain metals. The higher electrical resistance of aluminum means that for a given amperage, aluminum wires must be of a larger gauge than copper wires to carry the same amount of current without overheating. When aluminum wires are connected to devices such as outlets and switches made of different metals, the difference in thermal expansion rates can cause the connections to loosen over time. This loosening increases resistance at the connection, leading to overheating and potentially causing a fire. Aluminum also forms an oxide layer when exposed to air, which is non-conductive. This oxide layer can further increase resistance at connections. One of the most important steps in dealing with aluminum wiring is a thorough inspection. Look for signs of overheating, such as discoloration or melting of the wire insulation. Pay close attention to connections at outlets, switches, light fixtures, and in junction boxes. Use a voltage tester or continuity tester to verify the connections are solid and that there is no voltage drop across the connection. When making repairs, it is essential to use the correct materials and techniques. Old or damaged wires should be replaced. When connecting aluminum wires to copper wires, use connectors that are specifically designed for this purpose. These connectors typically contain a special compound that inhibits corrosion and helps maintain a good electrical connection. One common method for addressing aluminum wiring is to use pigtails. This involves connecting a short length of copper wire to the aluminum wire using a specialized connector and then connecting the copper wire to the device. This ensures that the connection to the device is made with copper, which is less prone to corrosion and loosening. Several types of connectors are available for making pigtail connections, including twist-on connectors, set-screw connectors, and crimp connectors. Each type has its advantages and disadvantages, so it is important to choose the right connector for the specific application. Twist-on connectors, also known as wire nuts, are commonly used for making connections in residential wiring. However, standard wire nuts are not suitable for connecting aluminum and copper wires. Instead, use wire nuts that are specifically designed for aluminum to copper connections. These wire nuts typically contain an antioxidant compound that helps prevent corrosion. Set screw connectors use a screw to clamp the wires together. These connectors can provide a very secure connection, but it is important to tighten the screw to the correct torque to avoid damaging the wires. Crimp connectors use a special tool to crimp the connector onto the wires. These connectors can provide a very reliable connection, but it is important to use the correct crimping tool and to follow the manufacturer's instructions carefully. In addition to making proper connections, it is important to follow good wiring practices. Make sure that all wires are properly supported and protected. Avoid bending wires sharply, as this can damage the insulation and increase the risk of a short circuit. Use the correct size of wire for the amperage of the circuit. Undersized wires can overheat and cause a fire. It is also important to protect aluminum wiring from moisture. Moisture can accelerate corrosion and increase the risk of electrical problems. Make sure that all wiring is installed in a dry location and that any exposed wires are properly sealed. Another option for addressing aluminum wiring is to install arc fault circuit interrupters, or AFCIs. AFCIs are designed to detect arc faults, which are a common cause of electrical fires. An arc fault occurs when electricity jumps from one conductor to another, creating a spark. This spark can ignite nearby combustible materials, such as wood or paper. AFCIs work by monitoring the electrical current in a circuit and detecting unusual patterns that indicate an arc fault. When an arc fault is detected, the AFCI trips the circuit breaker, cutting off the flow of electricity and preventing a fire. While AFCIs can be effective in preventing fires caused by arc faults, they are not a complete solution for aluminum wiring. AFCIs may not be able to detect all types of arc faults, and they can be prone to nuisance tripping in circuits with aluminum wiring. An alternative to AFCIs is arc fault detection devices, or AFDs. These devices are more sensitive than AFCIs and may be more suitable for use with aluminum wiring. AFDs work by monitoring the circuit for high-frequency noise, which is a characteristic of arc faults. When high-frequency noise is detected, the AFD trips the circuit breaker. If the customer is willing to invest in a more comprehensive solution, consider replacing the aluminum wiring with copper. This is the most effective way to eliminate the potential for overheating and arcing due to aluminum wiring. While replacing the wiring can be expensive, it can provide peace of mind and reduce the risk of electrical problems. When replacing aluminum wiring with copper, it is important to follow all applicable electrical codes and regulations. Use the correct size of wire for the amperage of the circuit and make sure that all connections are properly made. It is also important to install ground fault circuit interrupters, or GFCIs, in all wet locations, such as bathrooms and kitchens. GFCIs are designed to protect against electric shock by detecting small changes in the electrical current. When a ground fault is detected, the GFCI trips the circuit breaker, cutting off the flow of electricity and preventing a shock. In addition to making repairs and upgrades, it is important to establish a regular maintenance schedule for aluminum wiring. This maintenance should include periodic inspections of all connections to look for signs of loosening or corrosion. Connections should be tightened as needed and any corroded wires or connectors should be replaced. It is also important to educate the customer about the potential risks associated with aluminum wiring. The customer should be instructed to report any signs of electrical problems, such as flickering lights, warm outlets, or burning smells. By taking these steps, it is possible to safely and reliably operate electrical systems with aluminum wiring. However, it is important to understand the risks involved and to take the necessary precautions. Aluminum wiring connections need to be carefully maintained because aluminum expands and contracts more than copper with temperature changes. Over time, this can cause connections to loosen, leading to increased resistance and potential overheating. Always use connectors and compounds specifically designed for aluminum wiring. These products help to prevent corrosion and ensure a secure connection. Aluminum wiring requires a larger gauge than copper to carry the same amount of current safely. This is because aluminum has a higher resistance than copper. If you are replacing aluminum wiring with copper, make sure to use the correct gauge of wire. Consider the age of the aluminum wiring. Older aluminum wiring may be more brittle and prone to damage. If the wiring is old or damaged, it may be best to replace it entirely. Ensure proper grounding of all circuits. Proper grounding helps to protect against electrical shock and can also help to prevent fires. Document all inspections, repairs, and upgrades. This documentation can be helpful for future maintenance and can also be required by some insurance companies. Always turn off the power before working on electrical wiring. This is essential for safety. If you are not comfortable working on electrical wiring, hire a qualified electrician. Working with electricity can be dangerous, and it is important to take all necessary precautions. Aluminum wiring is more susceptible to damage from nail and screw penetrations than copper wiring. Be extra cautious when working near walls and ceilings with aluminum wiring. Rodents can also damage aluminum wiring. Take steps to prevent rodents from entering the building and inspect the wiring regularly for signs of damage. Over time, the insulation on aluminum wiring can deteriorate. This can increase the risk of electrical shock and fire. Inspect the wiring regularly for signs of deterioration and replace any damaged wiring. When working on aluminum wiring, avoid using excessive force. Aluminum wiring is more easily damaged than copper wiring. Use the proper tools and techniques to avoid damaging the wiring. If you are unsure about any aspect of working with aluminum wiring, consult with a qualified electrician. They can provide expert advice and ensure that the work is done safely and correctly. Remember that electrical work can be dangerous. Always take the necessary precautions to protect yourself and others. Working with aluminum wiring requires a thorough understanding of its properties and the potential risks involved. By following these guidelines, you can safely and effectively address aluminum wiring issues and ensure the safety of the electrical system. Aluminum wiring presents a unique set of challenges that need to be carefully addressed to ensure the safety and reliability of electrical systems. It is essential to understand the properties of aluminum wiring, potential issues, and the appropriate mitigation strategies. Here's a more detailed guide to provide a thorough understanding. Aluminum, while lighter and less expensive than copper, has a higher electrical resistance, which means that it needs to be of a larger gauge to carry the same amount of current as copper without overheating. Aluminum also expands and contracts more than copper with changes in temperature, which can loosen connections over time. Another significant issue is that aluminum corrodes when exposed to air, forming aluminum oxide, which is non-conductive. This corrosion can increase resistance at connections, leading to overheating and potential fire hazards. Firstly, conducting a detailed visual inspection is crucial. Look for signs of overheating such as discoloration, melting, or charring on the wire insulation outlets, switches, and junction boxes. Pay close attention to connections, as these are the most common points of failure. Check for loose connections, which can be identified by wiggling the wires gently to see if they move within the connector. Use a voltage tester or continuity tester to verify the integrity of the connections. A voltage drop across a connection indicates increased resistance and potential overheating. For repairs and replacements, use only materials that are specifically designed for use with aluminum wiring. Standard wire nuts are not suitable because they can lead to corrosion and loosening of the connection. Anti-oxidant compounds are essential to prevent corrosion. Apply these compounds to the aluminum wire before making any connections. The compound creates an airtight seal that prevents oxygen from reaching the aluminum, thereby preventing corrosion. Pigtailing involves connecting a short length of copper wire to the aluminum wire, and then connecting the copper wire to the device. This ensures that the device is connected to copper, which is more stable and less prone to corrosion. Use connectors that are specifically designed for aluminum to copper connections. These connectors are often pre-filled with an antioxidant compound. Some examples include twist-on connectors designed for aluminum wiring, set screw connectors with an antioxidant coating, and crimp connectors designed for aluminum and copper connections. Always tighten connections to the manufacturer's specified torque to ensure a secure and reliable connection. Under-tightening can lead to loose connections, while over-tightening can damage the wires or connectors. Replace any damaged or deteriorated wiring. If the aluminum wiring is old or shows signs of damage such as brittleness or cracking, it should be replaced with copper wiring. Ensure proper wiring practices by maintaining proper wire support. Use straps, clamps, or conduit to secure wires and prevent them from moving or rubbing against other surfaces. Avoid sharp bends in the wiring, as this can damage the insulation and increase the risk of a short circuit. Use the correct wire gauge for the circuit's amperage to prevent overheating. Install arc fault circuit interrupters, or AFCIs, to detect and trip circuits with arc faults, which are common indicators of failing aluminum wiring. AFCIs can help prevent electrical fires by detecting and interrupting dangerous arcing conditions. AFCIs are designed to detect specific arcing patterns and may not be fully effective with aluminum wiring. Arc fault detection devices, or AFDs, may be more suitable. AFDs are more sensitive and designed to monitor circuits for high-frequency noise, which is a characteristic of arc faults. For comprehensive solutions, consider replacing the aluminum wiring entirely with copper wiring. Although it is more expensive, this is the most effective way to eliminate the risks associated with aluminum wiring. When replacing aluminum wiring with copper, ensure compliance with all applicable electrical codes and regulations. Use the correct wire gauge for the circuit's amperage, and make sure all connections are properly made. Ground fault circuit interrupters, or GFCIs, are essential in wet locations such as bathrooms and kitchens to prevent electric shock. Establishing a regular maintenance schedule is critical for ongoing safety. Conduct periodic inspections of connections, looking for signs of loosening or corrosion. Tighten connections as needed and replace any corroded wires or connectors. Educate the customer or building occupants about the risks associated with aluminum wiring. Inform them to report any signs of electrical problems immediately, such as flickering lights, warm outlets, or burning smells. It is imperative to create a detailed documentation process. Keep records of all inspections, repairs, and upgrades. This documentation can be helpful for future maintenance and required by some insurance companies. Ensure electrical safety during maintenance and repairs. Always turn off the power before working on electrical wiring. If you are not comfortable working on electrical wiring, hire a qualified electrician. Electrical work can be dangerous, and it is important to take all necessary precautions. When handling aluminum wiring, be aware that it is more susceptible to damage from nail and screw penetrations compared to copper wiring. Exercise extra caution when working near walls and ceilings. Take preventive measures against rodents, as they can damage aluminum wiring. Implement strategies to prevent rodents from entering the building and inspect the wiring regularly for any signs of rodent damage. Over time, the insulation on aluminum wiring can deteriorate. Conduct regular inspections to identify any signs of deterioration and replace any damaged wiring to minimize the risk of electrical shock and fire. Use appropriate tools and techniques when working with aluminum wiring to avoid excessive force that can cause damage. If uncertainties arise during the process, always seek guidance from a qualified electrician. They can offer expert advice and ensure that the work is executed safely and correctly. By diligently following these guidelines, you can effectively manage and mitigate the risks associated with aluminum wiring, ensuring the safety and reliability of the electrical system. Properly addressing aluminum wiring requires a detailed understanding of its unique properties and the potential safety hazards it presents. Implementing a comprehensive strategy that includes thorough inspections, appropriate repairs, and ongoing maintenance is essential to ensure the long-term safety and reliability of electrical systems with aluminum wiring.